second method of preparation is from metallic nitrides. When oxygen is added, you call it as metallic oxide. Chlorine is added, metallic chloride. If nitrogen is added, it's called metallic nitride. Now we have two nitrides. You have magnesium nitride and aluminium nitride. What happens is, this metal is burnt in nitrogen to give you the respective metallic nitride. So we get magnesium nitride. Now here the valency of nitrogen is 3, magnesium is 2. So when you crisscross, you get Mg3N2. So this is the formula for magnesium nitride. There are 2 atoms of nitrogen, so 3 here. Aluminium is burnt in nitrogen to give aluminium nitride. Both have the same valency, both are trivalent, so they get cancelled, and the formula is ALN. So 2 here, and this is aluminium nitride. So this is the first step to form the metallic nitrides. The second step is, these metallic nitrides are mixed with warm water. So we take magnesium nitride plus water. This gives you the respective hydroxide and ammonia. Similarly, aluminium nitride also reacts with water to give aluminium hydroxide plus ammonia. Okay, there are 3 atoms, so this becomes 3, 2 here, so 6 here. So basically we have taken the nitride plus water here, and once ammonia is formed, the collection is the same as the laboratory method, which means the drying agent used is calcium oxide, and the collection also is by downward displacement of air. So that is the same, only difference is using metallic nitrides, but this is very rarely used. Why? Because it is expensive. Okay, so that much about the second method of preparation. Now we move on to the manufacture method, and the manufacturing method is called Haber's process. Now what's the difference between a laboratory method and a manufacturing method? Laboratory method synthesizes or prepares ammonia in a small scale, just like we prepare food at home, whereas manufacturing is in a large scale, like a food industry that provides for 1,000 people, 2,000 people. So that method is called Haber's process. This is simply a direct combination or synthesis reaction that happens between 2 elements, that is nitrogen combines with hydrogen to give a reversible reaction resulting in ammonia. Okay, and 3 here. So these are the 2 gases that combine to give you ammonia. This is what Haber's process is about. Now, according to this, there are certain conditions that are involved in this reaction. The first thing being, this nitrogen and hydrogen should be free from impurities. So they should be pure. Okay. This reaction is exothermic, which means heat is evolved. Exothermic means heat is evolved. In that case, initial heating is enough. Okay. When you come to the reactants and the products, there is one volume of nitrogen combining with 3 volumes to give you 2 volumes of ammonia. There is a reduction in the volume, which means the pressure should be more. So there are certain things the pressure should be, what the pressure should be, what is the temperature used, what is the catalyst that is employed. All those come under the conditions. So we move on to the conditions. The temperature, it requires a higher temperature, but always any reaction happens at its maximum at a temperature, that is the optimum temperature, that being 450 to 500 degrees Celsius. That is the optimum temperature under which this reaction happens. The next is the pressure that we need to use. This also is, it ranges from 200 to 900 atmospheres. Okay. Next we go to the catalyst. It's a catalytic reaction. What is a catalyst? It's something that can alter the rate of the reaction. In this case, it's a positive catalyst, which is finely divided iron. And there is also a promoter. Sometimes your mother becomes a catalyst for you. She can't write your exam, but she can improve your performance. And she needs, after working so much, she needs to boost up her health, maybe with a cup of Horlicks. That becomes her promoter. It increases the efficiency of the catalyst. Here the promoter used is molybdenum. Now there are also other options. Either you can use finely divided iron, or sometimes iron 3 oxide is also used as a catalyst. If iron 3 oxide is used as a catalyst, the promoter that is used would be potassium oxide plus aluminium oxide. This will be a combination of potassium oxide, that would be 1%, and 3% aluminium oxide. So this would be the promoter if iron 3 oxide is used as the catalyst. Molybdenum would be the promoter if finely divided iron is used as the catalyst. We prefer this, it's better, it's easier, you can study this. Okay, so temperature, pressure, catalyst and promoter. These are the conditions that we need to learn in Haber's process. Finally, how is this collected? The same, collection and drying are the same, which means it is collected, dried over calcium oxide and collected by downward displacement of air. So that is the same. Now, because it is a reversible reaction, there are chances that traces of nitrogen and hydrogen could also be present along with ammonia. So there are two ways in which we can remove nitrogen and hydrogen. One is liquefaction. To make it into a liquid, ammonia will liquefy at a very low temperature, that is -33, whereas these require still lower, so it's very easily liquefiable. So liquefaction. The second method is dissolution in water. To make it dissolve in water, ammonia is highly soluble in water, whereas nitrogen and hydrogen are almost insoluble in water. So these are the ways we can remove nitrogen and hydrogen and we get pure ammonia. So this is how Haber's process works.